In this segment, I'm going to talk about where the huge number of parsers for human language sentences comes from and how we might go about solving it in our statistical parsing systems. So a key part of doing parsing for human language sentences is this problem of what's called attachment from the psychological literature. It's for various kinds of phrases, how do we decide what they modify? So anytime we have prepositional phrases, adverbial or participial phrases, infinitives, coordinations and things like that, we have this attachment decision of working out what are they modifying. Let's work through an example to get an idea of that problem. So here we have a sentence. The board approved its acquisition by Royal Trust Co Limited of Toronto for $27 a share at its monthly meeting. And if we look at this sentence, well, what do we find? We find that, well, we have here the subject, the board, then a verb approved, and an object, its acquisition. But then if we look after that, what we find is that there are actually 4 prepositional phrases in a row. By Royal Trust Co Limited of Toronto for 27 cents a share at its monthly meeting. And for each of those, what we need to do is decide what are they modifying. So in general, a prepositional phrase can modify a verb. It can modify a preceding noun phrase, so it's got these 2 targets. But actually, each of these prepositional phrases actually includes in it a noun phrase. So once we get to the later prepositional phrases, there'll be more things that each one can choose to modify. Okay, let's go through each one in turn. Right, so for by Royal Trust Co, that's modifying the acquisition, not the approval. So it's acquisition by Royal Trust Co. So that's in dependency format. We have that relationship. Okay, of Toronto, this is not modifying the approval or the acquisition, rather it's Royal Trust Co Limited of Toronto. So this prepositional phrase is modifying Royal Trust Co Limited. Okay, so then if we go on to the third one for 27 cents a share, that's not modifying Toronto or Royal Trust Co. It's modifying the acquisition. So this is an acquisition for 27 cents a share. And then for the last prepositional phrase, at its monthly meeting, that's presumably not referring to an acquisition at its monthly meeting or any of these other things, but rather its approval at its monthly meeting. So this prepositional phrase modifies the first verb. Okay, that was kind of complex, though as human beings we just read the sentence and understand what it means and do these attachment decisions without any apparent effort most of the time. But the thing we want to think about for a moment now is how many possible attachments there are. Well, if you just sort of think there are, 1, 2, 3, 4 things here, and each of them could attach to a bunch of points, and each one can be chosen completely freely, it should be fairly clear that, well, we're going to get an exponential number of possibilities, exponential in the number of prepositional phrases. And it's precisely from that cause is where these huge number of parsers that we saw previously, like having 600 parsers for a sentence, came from. That really you are making a number of decisions for things like category and attachment, and a lot of them can fairly freely combine, so you multiply out these ambiguities and you get a huge number. However, it's not the case in examples like this. You're completely free to attach anything anywhere. So when we did by Royal Trust Co, it could certainly choose to attach either to the preceding noun or the verb. And then syntactically, when we attached of Toronto, it had 3 choices. It could attach to Royal Trust Co, or to the preceding noun phrase, or to the preceding verb phrase. And all of those were syntactically possible. But once you've made some higher attachments, that means earlier in the sentence, things become more restricted. So in particular, once we decided to attach for $27 a share as a modifier of its acquisition, that restricts the attachments that are possible for this prepositional phrase. It could still attach to a share, or it could attach to an acquisition, or it could attach to approved. But these ones here that are kind of hidden behind the attachment of for $27 a share to an acquisition, these ones become not possible anymore. So that leaves a kind of a little puzzle of, well, as you add on prepositional phrase attachments to a sentence, how many possible attachments are there that observe this constraint, which corresponds to dependencies not crossing, or for there being a tree structure to a sentence in a phrase structure grammar? Well, it turns out that the answer to that question is a well worked out piece of math. The answer can be found in the series of Catalan numbers, which is a sequence that turns up in a lot of places, wherever you've got kind of tree-like context. For example, it even turns up in probabilistic graphical models. And the important thing to know from our purposes is that the growth of the Catalan numbers is still an exponential sequence. We get an exponential number of parsers. Unless you're a math geek, working through the factorials there probably isn't the most useful thing to do, but rather it's probably much more valuable linguistically to actually look at what are the possible structures for a simple sentence and get a sense of how many there are there. And so that's what we'll ask you to do in the quiz question that follows this. Okay, you hopefully worked out in the quiz that the answer to, once you have two prepositional phrases, the number of possible structures is 5. But rather than focusing on that number now, what I want to start doing is focusing on the two problems that come from having this exponential possible number of parsers for even quite simple sentences. So problem number 1 is that if we parse naively, and that means that we use the simple kinds of top-down or bottom-up parsers that are normally used in contexts like in programming languages where they're used with less ambiguous languages, that would mean that our parsers end up doing an exponential amount of work themselves. And that's no good if we'd like our parsers to parse quickly. So where does that exponential amount of work come from? Well, the thing to notice is that we're generating this exponential number of trees, and that comes about from having a small number of basic ambiguities. So in this silly example, we have the two PPs with cats and with claws. We're choosing where to attach each of those. So there are really only two decisions, but we're then multiplying that out into an exponential number of parsers. And in the course of doing that, what happens is that we do a lot of repeated work. So if you look at these parse structures, you can see that we keep on building the same piece of structure over and over again. So here's a little PP of with clause, and we build it in this parse, we build it in that parse, we build it in that parse, we build it in every parse. We're always going to have that PP. But if we just generate all the structures, we're building it over and over again. And the same is true with larger bits of structure. So here's a bigger PP with cats with claws. It also appears in this parse, and so we're doing completely duplicated work there. And that goes on. So here's a verb phrase of scratch people, and we generate it in that parse, and we generate it in that parse. And there are other places in which we build other pieces of structure that get repeated over. So here's a noun phrase of people with cats, and here's the same piece of noun phrase of people with cats. Here is a verb phrase of scratch people with cats, and here is again the verb phrase scratch people with cats being generated a second time. So there's just a lot of repeated work. And so the secret to building efficient parsers and getting away from doing an exponential amount of work is to avoid doing the same work twice. We only want to find possible pieces of structure for a sentence precisely once, and then we'll be able to turn parsing from an exponential problem into a polynomial time problem. The problem is then how to choose the correct parse or several likely parsers out of the many possible parsers for a sentence. How can we do that? Well, let's look at this simple example. So this is again the classic, here's a verb with an object-noun phrase and a prepositional phrase attachment following it. So it could be that this modifies the verb, so she is looking through a telescope and she saw the man with the telescope, or it could be that this modifies the noun, so this is a man with a telescope and she saw that person. Well, which of those is correct? Well, the answer is that it could be either. So this is what's commonly referred to as an AI complete problem. Knowing which is correct could depend on arbitrary knowledge about the world situation that's being observed, or the prior discourse context in really complex ways, and it can be really hard to tell. Well, that's true, but it turns out that in a lot of cases you can be pretty sure what's correct without understanding a lot. That just looking at the words that are involved, the nouns, the verbs, and the prepositions, you can get a really good idea of which attachment is correct, even without having anything like full understanding of the sentence. Let's look at a couple of examples that illustrate this. Okay, so here is now some more real text examples. They have exactly the same structure. So we've got a verb, a noun phrase, and our prepositional phrase. Moscow sent more than 100,000 soldiers into Afghanistan. So one possibility is that the sending is into Afghanistan, the verb attachment, and the other possibility is it's soldiers into Afghanistan. Now, syntactically, either of these is possible. So soldiers into Afghanistan would have the same structure as a phrase like whatever, students into Lady Gaga or something like that, right? It's a possible syntactic structure, but it's just really unlikely. You're just very unlikely to have soldiers into Afghanistan. And so almost certainly the structure that we want to choose is with into Afghanistan modifying sent. And that's a very common idiom, that you send something into some environment. And so we should choose this parse. Then let's look at this next example. So in this example, same structure again, and we can have the PP with New South Wales head being a dependent of breached with New South Wales Health, or it can be a dependent of the agreement with New South Wales head. Well, again, breaching with New South Wales head just isn't very likely. You just don't say, I breached with my friend. Doesn't sound very good. On the other hand, an agreement with New South Wales Health, that's really common and normal sounding, because you make agreements with somebody. And so this is the attachment that we should choose. So that then didn't look that hard, and that's exactly what we'll do. Our statistical parsers will try and exploit such statistics about word combination, which kind of preposition is likely to go with which nouns and which verbs, to be able to choose the correct parsers of sentences without having full understanding of them. Okay, I hope that's given a sense of how parsing human language sentences can just be a really bad problem, but also some idea of how we can start developing methods that will solve both the problem of there being an exponential number of parsers, not causing an exponential amount of work, and how we choose the most likely parsers for sentences.